Okay, let's try to go through this stuff for alternating series. We'll have a couple of extra topics towards the end dealing with absolute and conditional convergence, and then we'll also look at the error bound for alternating series also. But let's do the alternating series test first, then we'll go through those other two things. First thing, obviously, you need to always watch out for. If you're going to use the alternating series test, you had better make sure it's an alternating series. If it doesn't alternate, plus minus, so on and so forth. If it doesn't alternate, why in the world are you trying to use the alternating series test? That's stupid. Don't be stupid. If it doesn't alternate, you would need to use one of your other tests that this packet teaches you. But if it does alternate, this test is actually a really easy test for us. So just always be on the lookout. This -1 to the n plus 1 power, or this -1 to the n, that's the most frequent way how you're going to see these series alternate, right? If this is an even power, the negative to the even power would just cancel. And then, hey, if you plug in 1, you'd have an odd exponent, so then the negative would end up staying. So as long as this exponent is going to alternate between evens and odd numbers, sometimes the negative will stay, sometimes it's going to go, and you'll have that series alternate. You have to be careful, though. If you have something like this, where you have the -1 and the exponent is 2n, well, no matter what term you plug in for n, 2n would always be an even number. And if you always have an even exponent, that negative is never going to be there. It always is going to cancel. On the other hand, if you have an exponent that's something like 2n plus 1, or it could be 2n minus 1, or it could be something like 2n plus 7, or 2n minus 5. If that exponent is always going to end up being an odd number, then the negative would always stay. It's not going to alternate. So just be careful. It doesn't take that much brain power to look at the original series and determine if it's going to alternate. Just be careful for the ones that are only even powers or only odd powers, because those may look like it, but they're not going to alternate. All right, let's read through this test. Okay, so it says the alternating series test says let you have some sequence greater than 0. The alternating series, again, you have it to the -1 to the nth power, or your n plus 1 power. That's going to make sure it alternates. That alternating series is going to converge if the following two conditions are met. Here it says the limit of the sequence is 0, so the terms are going to get closer and closer and closer to 0. And then this says a sub n plus 1 is less than a sub n for all n. That means the next term, here a sub n plus 1, that's your next term. That next term is always smaller than the one right before it. And those two really can be lumped together. If you think about, hey, if the limit is 0, that means the terms are going to have to get smaller. Of course, we have positive terms. And if the terms get smaller, the next one should be less than the previous, right? That makes sense. In other words, and this is kind of how I usually remember it, if you want an alternating series to converge, three things are going to have to happen. It's going to have to alternate in sign. It's going to decrease in magnitude. That's what this is telling you, right? All the terms are going to get smaller in size. And then they need to have a limit of 0. And really, these two, you could kind of sandwich together. You could just say, hey, it decreases to 0, and that's kind of killing two birds with the one stone. But they need to alternate. Duh. If they don't alternate, do not use the alternating series test. But if they do alternate, then you're just going to check what's the limit. And if the limit is 0, that means the terms get smaller in size. You're going to be good to go, and it's going to converge by the alternating series test. Really quick, really easy test. Let us go through some examples. Now, notice it says, hey, like, if this first condition fails, like if it doesn't alternate in sign, that doesn't mean it's going to diverge. That means you shouldn't be using this test. And then similarly, if one of these conditions fails, if the limit's not 0, or they don't decrease down to 0, if they don't get smaller, well, it wouldn't diverge by the alternating series test. If the limit's not 0, then it would diverge by the nth term test. Just be careful. If it fails one of these conditions, it diverges by the nth term test. If for some reason it fails the first condition, you're using the wrong test to begin with. Use something else. If it doesn't alternate, don't use the alternating series test. All right, first example. So just going to check those three things. You need to see, does it alternate? And then if it does, is the limit going to end up being 0? Here we see they got the -1 to the n plus 1 power. Great, that's going to make it alternate. That's good. But now let's look at the rest of it. We can kind of do this limit in two parts. I'm only going to split it up and do the limit two parts for these first two examples. Then we'll kind of smush them together and do it all at once. But I'm going to collect all the positive terms, and I'll look at, hey, as n gets bigger and bigger and bigger, as n goes towards infinity, what are those collection of positive terms going to get closer and closer and closer? Then we'll also look at all the negative terms, because this chunk right here, that's either going to be a positive one or this chunk is going to be a negative one. So you can kind of collect all the positive terms, do their limit. You could collect all the negative terms and do their limit. It doesn't really matter. We're not going to split it up throughout the rest of this notes, just for the first two examples. But here it looks like if I were to evaluate either of these two limits, for the positive terms, it looks like they're getting closer and closer and closer to 1/2. For the negative terms, looks like they're going to be getting closer to -1/2. Well, that limit isn't 0. Similarly, the negative terms are also not getting closer to 0. So if the limit's not 0, diverges by the nth term test. Super quick, super easy. If the limit's not 0, diverges by the nth term test. Okay, let's look at the next one. Again, that -1 to the nth power is going to make it alternate in sign. How wonderful. Then I'm going to look, hey, the limit of the positive terms, remember that would just be a positive 1 on the top, or here for the negative terms, it'd be a -1. But if we were to look at the limit of all the positive terms, they're going to get closer to 0. And if I look at the limit of all the negative terms, they're going to get closer to 0. It's important that both of them must be 0. And if so, I know they're alternate in sign. You don't really have to do any work for this first condition. You're just looking at that original series and you're just kind of investigating it mentally and concluding, hopefully, that it does alternate in sign. So check. And then really these two, I kind of have the note over here on the right, those two you can kind of lump together and you can prove both of them with this limit. Decrease in magnitude means the terms get smaller in size. So if I were to plug in n equals 3, that term should be smaller in size. You don't care about the plus or the minus, but it should be smaller in size than plugging in n equals 2, or so on and so forth. The 17th term should be smaller in size than the 16th term, or the 81st term should be smaller in size than the 80th term. Right, so decrease in magnitude and then the limit being 0. If the limit's 0, they're going to decrease in magnitude. So really, that's the only math work you need to do. But you need to alternate in sign, decrease in magnitude, limit to 0. And if you get check, 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 you can go ahead and say, therefore, this series converges by the alternating series test. If you wanted to do some work for decreases in magnitude, you could do some. It's not really necessary. The limit work is enough and it is sufficient to get you all the points that you need. But you could kind of do something like this. Let's see, I think it's off the camera. You could do something like this where I look at, hey, some arbitrary term, I plug in n. Then you look at the next term, so you could plug in n plus 1. And then if you can easily tell which one's bigger, like here, since that denominator's bigger, that means this fraction as a whole is going to be smaller. So that will really quickly and easily tell you that my next term is going to be smaller than my previous term. That's another way to show that it's going to decrease in magnitude. Or, remember how you can show that something decreases? If you look at the first derivative and it's always negative, that's also a perfectly good, valid mathematical way of showing something to decrease. So you could kind of just ignore the plus or minus 1, because again, magnitude means you don't care about the sign. But if I were to just look at, let's say, 1 over n squared, think about that as like your function. If you were to take the derivative of it, it should be always positive, or sorry, it should always be negative. That's my bad. It should always be negative. Now you're only needing from n equals 1 towards infinity. So like that whole first derivative may not always be negative, but from 1 to infinity, that first derivative of this term should be negative. Lots of different ways to show decrease in magnitude, but really all you need to do, you can get both of these conditions with just the limit work. And if you have alternate in sign, decrease in magnitude, limit 0, check, 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 you just say this series is going to converge by the alternating series test. All right, pretty quick, pretty easy. Let's look at the next page of examples. Here's the first one. Again, it looks like it's going to alternate. Awesome. But then when I investigate the limit, instead of breaking it down and doing the positive terms and the negative terms, you can kind of just get them all at once and just do plus or minus. But if I look, right, this part's either a positive 1 or a negative 1, so you can just put the plus or minus, and that's fine. But if I were to look at the rest of the limit, you're going to get 3/4. 3/4 isn't 0, so diverges by the nth term test.